What we're going to talk about today is about doing cloud-native compliance. My name's Chris Butler. I was one of the founders of OSCAL-Compass and one of the compliance Trestle. And
my name is Takumi Yanagawa from IBM Research. I am also a maintainer of OSCAL-Compass project, and I am working on the research area of compliance automation. Thank you very much today.
So what's actually pretty exciting for us is this is a new project inside of the CNCF. We only became sandbox last year. So it's really great to see such a crowd here for what's a pretty niche project. But what we do realize is everyone has a lot of pain. So anyone who's sitting inside of an enterprise feels pain today with compliance, particularly if you're a software engineering team. Every once in a while, you get a big spreadsheet that you have to fill out, and you just don't want to. And from my perspective, I work across all parts of Asia Pacific, work with colleagues across Europe. We know that regulatory complexity is getting, it's getting much more complex for us over time. All of the geopolitical stuff, we don't really want to talk about. What we know that it means that we go and do something in Australia, we go and do something in Japan, we go and do something in the US. Everyone wants to do something slightly differently. Technically, it might be exactly the same thing we need to do, but we need to re-articulate it all the time. The other one that we have is, big challenge we have is we know, working and being here at KubeCon and Cloud Native Con, is that the technology is always changing. The people we deal with from a regulatory perspective, they would like it if we never ever changed. So how do we work with teams who don't want to see change at all, but we need to be able to articulate those changes in a consistent way to them in a way which they understand? The other one that challenge we really have with compliance is that tooling is really isolated. So if I go and talk to some regulatory compliance people, they'll want to buy this fancy GRC tool, and it will help them do all of these nice legal mappings, but from our perspective as technologists, it's almost useless. We go and talk to the security teams, and they'll have a whole pile of security tooling, but they'll have no understanding of regulatory environments. It's completely devoid of that content. So we find that, and then when you talk about what will I do with an external team, if I went to an auditor, what do they really want today? Please send me the screenshots. So screenshots is not an efficient way of doing things. And if you think about doing things at scale, how do I send screenshots of 500,000 physical machines, BMC consoles? You can't do that and scale. So this is what we really have a challenge is, one is spreadsheets are, a really cool invention from technology, but also our worst enemy. Spreadsheets are not consistent, they're not version managed in a way which, but they're de facto glue between all of these teams. And this is what we really wanted to get away from. And alongside that are these professional services organizations, whether it's the accounting firms who are doing SOC-style compliance, whether it's the 3 PAOs in the US, the US system, or whether it's in Australia, they call IRAPers. All of these people are driven by human-centric processes, and they just don't scale for cloud-level compliance, particularly if you're an infrastructure provider, or even worse, if you're a PaaS provider and you have hundreds of services, you have to do these hundreds of times. And the individual audits might be potentially millions of dollars to do. So we know that this is really challenging, it's really expensive, and it's really driven by human glue. And what we've been trying to work on is how do you start to get away from this? And we know that there will be human-centered controls that you won't get away from some of these high-touch things. When you have a control which says, I need a CISO, you have to kind of verify there is a CISO. But if the control says it needs encryption, which will be our demo today, that's something which we can prove using machine-readable tools. So we're talking about a project called OSCAL-Compass. So the first thing is, what is OSCAL? Well, OSCAL is really a high-level data model that came out of the US government, so out of NIST. So if you've dealt with SCAP before, it's the same team who have built this. And it's really about building a data model which doesn't just talk about configuration, which is what SCAP is. It talks about the entire process of compliance. So they effectively, there's 3 phases. And the way I think about it is the first phase is what do I need to comply against, which is the catalog and the profile model. And the easiest way I think about it is what does the regulator do? Or in some organizations, it'd be what would your internal compliance team build? So we've got a model for, okay, here is all the objects I have, here are all the dependencies, here's how I structure it. So as a technologist, I can get down to the individual line items, but really at this stage, it's mostly human readable prose and a few parameters. So it might be which types of encryption algorithms are okay, might be some of the parameters. The second one is really how do you present out information about what you've done? How do you describe what you've done? And those things are called system security plans. How many people have had to build a system security plan before? No, yes, hello, back there. So there's two sides to this. Effectively, a system security plan, unlike the kind of SCAP view of the world, SCAP is how did I configure a Linux system, typically, or a Kubernetes cluster. But the reality is any cloud service is not going to be one Kubernetes cluster. It's going to be multiple clusters across multiple regions, if you're lucky, if it's not tens of clusters across tens of regions. So that system is the system which I'm presenting to an end user. So that's that larger sense of a system. But the question is, how do vendors, or I work for Red Hat, so how does Red Hat help you? Well, we need to be able to provide information about the components you have in there, and that's the component definition, is really that vendor statement. So that's how do we provide information about what you're doing, how you describe your system in there, and then how do you run through an audit life cycle? So audits have plans. What do I want to audit? What is my sample, as well as the results and potentially the mitigations? So these set of data models, they're incredibly rich, but they're also, to be quite frank, pretty complicated. So the next question is, how do we try and simplify the experience for end users, for technologists, or people who are engaging around the ecosystem, like these spreadsheet-driven compliance officers, into so that they can connect to OSCAL, so that you can consume these machine-readable models and really build the automation that you want. So there's a project that has been created called OSCAL-Compass. So it was initiated with IBM and Red Hat, but we've got contributions from across the ecosystem. So we're starting to get contributions, as an example, from the US government, from people who are working at some of the hyperscalers, as well as even people at Meta as well. And there's kind of three components we have in it. One is compliance Trestle, which is effectively an opinionated way of dealing with OSCAL in a Python SDK. And the easiest way to think about Trestle is trying to provide that layer and a set of tooling to sit between humans and the 300,000 line plus JSON objects. Because once you get to these big standards, they're huge objects. Typically, they would have been multi-thousand page Word documents. There needs to be an SDK layer in there to make things simpler. Agile authoring, which is really our view of how do you do this with GitOps. So you can really view agile authoring as an implementation of using compliance Trestle and compliance to policy. And compliance to policy, or C2P, which is Yana-san's piece, which is really how do we go, now I have standardized information, standardized formats. That means we can get to the point where we can link it to executable code. Because all the pieces I said before, yes, it's a data model, and yes, it produces standard objects and means that you don't get into spreadsheet hell, but it still doesn't mean you have executable code, and that's what compliance to policy is about. So today we're going to try and look at a really simple example of how you can drive this, and Yana-san's going to drive a lot of the components here. So we're going to kind of go from the control that everyone understands, which is how do I enforce encryption. So our definition of enforcing encryption in this case is something that we know every developer does, which is they turn SSL off because they don't have certificates at that point in time, or TLS off, and they want to have a really simple test of, can I get to port 80? So we're going to try and enforce that TLS is in there. So the way in which we're doing is we're starting from NIST 853, which is US government standard and has been propagated across many regions, and our control enforcement is going to be with Kyverno in this case. So normally we deploy this with Argo CD. We're going to do a bit of cheating for the purposes of demonstration because no one wants to wait for a reconciliation loop while we're standing here. And Kyverno is going to be used to enforce the policies on the ingress. So we're going to start with an observation of what's good and bad. and then be able to really make sure that it's actually remediating the problem rather than just observing what's going on there. So just to kind of put that in a different way, and look it on time. We're going to start with the compliance requirements, and compliance Trestle is going to go from, in this case, an Excel document to the JSON that we need. So we're going to use that as a subset, provide you an example. And then compliance to policy is going to be targeting and pushing that Kyverno policy out, and then making sure that we can get that reporting back, so you can think about how am I starting to close the automation loop for my auditing lifecycle. How can I start to collect all the information that I need so I know what my compliance posture is? And really the benefit of that being that I can get to that continuous authority to operate or continuous measurement of compliance for arbitrary controls. But over to you, Hannah.
So today, I would like to showcase this pipeline in demonstration. So as Chris says, this is very helpful to end-to-end automate continuous compliance. So and the starting point is the high-level compliance requirement that's simple. NIST 853 SC3. This is the original OSCAL format. This is very long and it's quite difficult to read. But the essence is that this is about encryption, about the compliance, about the encryption protections, and it's implement the, for example, TLS establishment. So we focus on this SC13 controls. And the corresponding Kubernetes policy is this one. It's targeting against the ingress. And this is the validation logic to check if the ingress resource is correctly configured as TLS configurations. So now, we have to create this Excel file. Actually, we have to create an OSCAL component definition. That's define each component information. In this case, the first row is about Kubernetes. The second row is validator, Kubernetes. And also, it contains mapping of SC13 rule and Kubernetes policies. The mapping Kubernetes policy is these policies. So now we follow the GitOps operation, GitOps automation. So this Excel file pushed into the GitOps. So I'll go back to code. And this is the compliance pipeline integrated to GitOps. And we just push this CSV into this repositories. So then uploading this CSV will be converted to the OSCAL component definitions. So let's commit. So now the GitHub action starts. This is the similar structures of the pipeline that we showed in the slide. It's a bit small, not bigger. And the first pipeline is converting to the CSV into OSCAL component definitions. The OSCAL component definition looks like this JSON. It contains all information about the mapping between policy and controls, and also the validation component information. So now that it's finished converting CSV to OSCAL format. Next is generating Kubernetes policy from this mapping rules and deploy to the policy into my Kubernetes clusters. Now it's finished. Actually, you can see the deployed policy. This is our deployed policies. Now the Kubernetes produces the policy reports as a policy validation result. And this pipeline gathers the reports and normalized into the OSCAL format. And then finally, this normalized OSCAL format is converted to the human readable format, such as Markdown, and then finally create a pull request to review the CISO security engineers. So let's just 10 seconds wait. I produce pull request like this. So this pull request contains the compliance informations. This is about NIST SC13's controls, and the compliance status is we have two applications. One is a good application. It's good configured as a TLS. Another one is just 80 port, using 80 port HTTP. So we can check this kind of compliance check in the fully automated manner. So also we can, this is just a check process. But another thing, important thing is remediation or enforce the policy. So Kubernetes supports, it depends on the used policy engine, but Kubernetes supports enforcement of the policy. So we can utilize it. So we just edit this, the Excel sheet. We have introduced one parameter that to enable enforcement or not. So just change these parameters and then save this, and the rest process is same. We push this edited file to GitHub. Then we can obtain that. Okay, we have a few seconds, so let me push this one. Upload this one to, okay. Oops. Yeah, it sometimes happens.
We did set it as live.
This is live demo, so. Okay, anyway, so the final pull request looks like this one. I have some trials, so okay, check. Not this one. Okay, this one is good examples. So once we done remediation policy, then the two application turn into the green marks. So this is our pipelines. To just a second, let me bigger. So using OSCAL-Compass technology stack, we can enable this kind of continuous compliance automations in the GitOps. So, please.
Yeah. So just to kind of jump in there, if you think about it at a more abstract level, what do we really enable? I mean, there are a set of stakeholders who are interacting with their Excel or CSV, and when you pull, it gets pulled into the technology teams. It gets pulled into, into the JSON and into, in this case, GitHub, but it could be into any source code management platform. And what does that really mean? All the tools that you have around release management and pull requests are there. So if you think about it, compliance just becomes an extension of DevSecOps, the DevSecOps, or whatever you want to call it, but it becomes that real platform that you don't as a developer have to move anywhere else, and you don't have to really introduce another tool. It's just another platform. It's just another extension of the same operating model that you have. So that's the goal what we have. So what are some of the challenges? I mean, there's a lot of compliance tooling. There's a couple of large proprietary platforms which are really locking people in. So one of our objectives is how do you grow the open ecosystem? The challenges that we have, especially if we're developing upstream products, or upstream projects, is that a lot of this is an enterprise concern, but we know it flows back onto the upstream products and projects, but you can't afford these commercial products which are designed around organizational life cycle. So helping be able to produce component definitions and articulate some of the key security features in a way which is more consumable to enterprises and in a standardized way is one of the things that we're really excited about. With the work that Jana showed on C2P, we showed Coverno, we've done OPA policies, we've done open cluster management policies and SCAP. We've got multiple tools which we've integrated with, but really it's a toolbox. Actually, both of these platforms are toolboxes which can be expanded. So we really want to have people contribute as well and test it out and play with the ecosystem as well. I did mention one of the challenges is of standards adoption. You saw us show two things which came out of NIST. One was the specific regulation, which was 853, and the other one was the underlying standard. A lot of people will push NIST 853 on anyone who can talk to, just to make their life easier because they've already implemented it once. But from someone who's as far away from Washington as possible, what we don't really want NIST 853. What we want to be able to use is those underlying data models. So it's, are these data models useful, powerful? What are the gaps? The NIST team has actually been really proactive in engaging with us. Some of the parameterization pieces have been things that the extended team which has worked for this has fought for. So there's some of the kind of the open challenges around the ecosystem. The other one, if I kind of zoom back out about where some of the challenges are, is what you described is really great, and it's really great if you can get an auditor to buy in and understand. In some environments, it's really been enforced. So if you do work with the FedRAMP program in the US, you have to produce OSCAL effectively now. But that means that there's a greater ecosystem that has to exist. So those JSON artifacts, there's nothing to stop me from changing the dates in them. There's no kind of authoritative signing or attestation process for what is good evidence and when did I create it. And the other one is how this flows across cross-organizational boundaries and trust. So while we've got the standardization, the way I would describe it is you can standardize pretty well within an organization, but when you go across organizations, we don't have that PKI infrastructure for compliance there yet. So there's a few things to grow to, but that I think means that there's opportunities for some really cool projects to be built as well over the next few years as these tooling platforms evolve. And the one thing I will say before we get to the end is there are community calls. For those of us who are in APAC, there is an APAC-specific community call as well, which is at a reasonable time. I know it can be a bit of a challenge for many projects. Everything is on GitHub. If you have any questions, please reach out. We're on CNCF Slack as well under tag security. So if there are any questions, there are people here. There's people in Australia, Japan, India. We've got some developers in China as well. So if there's anyone interested, just please reach out. I'm more than happy to help and see what if anyone's interested. But thank you very much for coming at the end of the conference as well.